everyone. Hey, welcome back to another remote session today. So today we are going to extend our discussion from last time. If you recall, last time we talked about a new data structure in doubly linked list. So today we are going to add two more operation to doubly linked list, the so-called delete and search operations, right? So firstly, let's follow up on the activity that we did last time. I like to go over with you guys the code for implementing the add lost and add reverse functionality, right? So if you recall, we had three different files. I like you to open those files. Please pause this video for a second and open the link stub file. So you would see that we had added a method here called add friend, and then we added a method called display nodes reverse, right? So I like to go over the implementation detail. So in order to do the add friend method, so I really copy the code from the add loss method, and then I'm going to place that in add friend, right? So really we are adding something to the front of the list. So the way we should visualize this here is, firstly we get a number with the value 0. The next time you get 1. So you add something to the front of the list like this, and then 4. So the way you read it is 4, 3, 2, 1, 0, right? When you add something to the front of the list, this is how it would look. It's worth recalling that when you add something to the end of the list, then this is how it will be added, right? So a new element would be added to the end of the list, right? So really what we are doing here is then we need to add something to the front of the list, right? So I like to go back to that code here. So I had copied over the code from the add lost. First thing first is we check if head is null, we set temp.setNext is null, temp.setPrevious is null, head equal to temp, tail equal to temp. No major changes in that code, right? So when head is null, your linked list is empty. You're simply adding the new node, right? Else, if the linked list is not empty, so this is where we have our work to be done. So we need to set node current equal to tail. Remember, we are adding something to the end of the list, right? So we are adding something to the tail of the list, right? So while current dot get previous, because this is a doubly linked list, so we are checking the previous node for that tail node. If it is null, if it is not null, then you simply go and update your current to current equal to current dot get prev, right? So what you're doing is you're going previous node, previous node, previous node like that, all the way to the I would say end of the list, right? So again, let's visualize this. So we got 0, and then 1. So you go for the tail node, you check, right? This is my tail node. You check that, hey, tail node, can you look at the tail node and then see if the previous node is not null. Then simply you're going to add the new node to, you set the new node's next node to be that particular current node, right? So the temp node that's coming in right here, which is 2, we need to set that the next node to be 1, right? So that's what we will do here, is we need to set, this time around we need to set temp dot set next is going to be current, and then current, keep in mind you need to update the current nodes set previous. Current dot set previous is going to be temp, right? So really you're updating temps set next to be current, currents set previous to be temp, and then temps set previous should be null, right? Not set next. Temps set previous should be null, and finally you update the head of the list to be the temp. You see, so the head of the list is to be temp, which is what we got right here. We start from the tail. Keep in mind 0 is the tail, 0 is the tail right here, and 2 is the head, right? And then if I add a new element, let's say 3, if I add 3, then 3 becomes my head, 0 still remains the tail, right? 0 still remains the tail because you're adding something to the front of the list, right? And if you add 4, simply you add 4 to the chain, right? So 4, 3, 2, 1, 0, so on and so forth. All right, so that's the link.java, and the size plus continues to be the same. So let's also go ahead and implement the display reverse, right? So again, I like to copy the code from display forward. Keep in mind, all these code is going to be implemented in a similar way. So this is why it's important for us to understand how we can modify a particular code to behave differently, right? Because they're all kind of similar, right? So when I asked you guys to implement this section last time, it shouldn't take much time if we really understand the logic, right? So grab a paper and pen and then draw these chains yourself. The way I implemented, I do exactly the same thing, right? I grab a sheet of paper, I visualize it. The moment it is clear for me how to visualize it, then I can implement it so easily, right? So again, we could prove that here by simply copying and pasting the display node forward, and this time we are going in the reverse direction, right? So should it be the head or tail? So I'm sure you guys would agree that it would be the tail, right? So, and then keep in mind, because it's the tail, we need to go in the previous direction, right? So we need to update current equal to current dot get previous, right? And then we say over here we are simply printing current dot get data, and then we are printing the end line, right? So no major changes. You see how easy it is to modify a particular method, display node forward, and create the reverse with a simple change, right? We updated the tail and we said current equal to current dot get previous, right? Okay, well, we may run into some errors, but I would like to go over this complete thing with you so you could see the process of error solving and producing the correct result, right? All right, so now we updated that. Let's save this program, and I like to, at this point, run this program here. So let me compile. So now we will try to compile and run this program here. Okay, well, the program did compile without any errors, and I am getting the result, which is not something that I like to get, right? You see how these two links are like kind of combined together? Why is that? Why is that the case? Why did we not get it as two different links? So can we go over that particular point together in links tab.java? So really you could see that we are maintaining only one link when we said we want to add last or add friend. We are adding it to the same link, and thereby you could see that we run into this problem that 43210 then 01234, so 10 nodes are added into one link, right? So that's not something that we ideally would like to do, right? So how do we change that? So really, the way we modify our code to do that fix is simply, adding a link 1 and link 2, right? So I simply add link 1, and then I copy this line, I put it right here with link 2, and then this is going to be link 2, this one is link 2 again. And keep in mind, we need to update this one as link1.size, and I would say that total number of nodes, let's say total number of nodes for link 1, right? And then copy this and put this for link 2. All right. So now that we had done that, let's go ahead and recompile. So you can see now you're getting it as two different links, right? So link 1, we had added it to the end of the list. Link 1, we added to the front of the list, and then we do the reverse, right? Forward and reverse printing. And you could see the number of nodes are 5, right? All right, well, that's the follow-up from our previous discussion. I'd like you to pause this video for a second and then implement these yourself, fully, so that you match my result, right? So the next thing that we are going to do now is we would like to add a new method called delete, right? So let's add that method, boolean. Let's say the method returns a boolean. You want to say delete node, and you give a value, and then it will delete that particular node from the linked list, right? So I'm simply going to say return false for now, but then we will implement our logic here, right? So let's say that add your logic. Okay, so there are three cases here that we would want to implement. So what if the linked list has only one node, right? The last node. So I'm going to quickly use up the space here. So I'm going to say case 1 is linked list or doubly linked list has only one node, right? So then we need to delete that. If you delete that, then the doubly linked list is going to become empty. So we will say head is null, and then tail is null. Right? C2 or case 2 is where we say the node to be deleted is a head node, right? If it is a head node, that's case 2. Case 3 is node to be deleted is a tail node. Case 4 is where we say node to be deleted is somewhere in between head and tail, right? So there are multiple cases for us to look at, right? So really we need to take care of all these cases. First thing first is we say if doubly linked list has only one node, which means then both head and tail are pointing to that node, then we set head equal to null, tail equal to null, right? So I like to implement that case. So I will say if head dot get data is double equal to the value and tail dot get data is double equal to value again, right? So which means both head and tail are pointing to a value. That means then there's only one node, right? Only one node in that linked list because both head and tail are pointing to the same node, right? So then I would say head is null, tail is null, and then we simply need to decrement our size. We return true, right? Return true meaning we deleted something from that particular linked list, right? Else, then we implement the other three cases, right? So let's set up the case 2 where we say head.getData is double equal to value, which means then we are trying to delete a head node. Else if tail.getData is double equal to value, else somewhere in between head and tail, right? If it is the head node, what should we do? Again, it's a common sense, right? So you can go ahead and grab a sheet of paper and then ask this question yourself. If it's a head node, what should I do? If I have 5, 4, 3, 2, 1, let's say, right? And this is my head node, right? 5 is my head node. If this is the case, then what should I do? I'm going to set my head node to be the next node in that sequence, right? So head node should be pointing to the next node in that sequence, right? So then we need to update that head node. Let's do that update. Head is simply equal to head dot get next. But keep in mind, we need to update the pointers there, right, on both direction. So 4 now should be pointing to the null, right? So because the head node has been removed, so the way it looks like is going to be like this, right? So 4's next node is going to be null node, right? Or I should say 4's previous node should be null node. But before we do that, we need to also set the next node for 5 to be null. 5 now is pointing to 4. You don't want to do that, right? So we have a couple of things to take care of right here, right? So I'm going to go back and I would say head dot get previous, which is nothing but 5 in this case. Set next is null, right? And then you do head dot set previous is null also, right? So that's now 4. 4's previous node is null. 5's next node has been set to null. Then you decrement size and you return true. So you kind of do the same thing for the tail as well. So I like to copy that, place it for tail, and again visualize this for the tail. I like you all to visualize it yourself. So tail is equal to tail dot set previous, get previous, right? So really we are going one node. If this is 5, 4, 3, 2, 1, I like to say that this is my tail, right? If you're removing the tail, you need to take care of that. You need to make 2 as the new tail, right? So 2 now becomes the new tail. So what do you do then if you want to update that? Firstly, you need to update your tail to be pointing to 2, which is the previous node, right? So that's the previous node. And then you need to keep in mind, so the new tail, which is 2, 2's next node should be null. 1's previous node should be null also, right? 1's previous node is right now pointing to 2. So the way you set that is 1's previous node should become null, right? So again, let's go back to the code. So tail equal to tail.getPriv, right? Tail. So really, you're looking at the tail.getNext after you update your tail. and the previous node should be null, right? And then tails next node should be null also, right? All right, so you can see we updated all the behavior of the code, and again when we say tail dot get next dot set prev, we are referring to 1, right? Because 2 now become the tail. Get next is 1. One's previous node is set to be null, right? And then 2's next node is set to be null also, right? So really you're breaking the chain by setting things to null, right? All right, so that's the else if condition. Let's go ahead and add the else condition, right? So else condition is where you say, okay, well, I need to run a loop, right? So I need to run a loop by setting node current is equal to head, while current is not equal to null, current equal to current dot get next, right? So here I'm going in the forward direction to do the search, but one could also go in the backward direction as well, right? As we implemented the reverse functionality earlier, so one could also easily go in the reverse direction. So here I check if current dot get data is double equal to the value. If this holds good, so simply we need to decrement size, return true, but keep in mind we never did anything to the chain yet, right? So I like to update the chain. Let's clear up the code a little bit. Okay. All right. So what's the logic we need to apply right here? Again, we need to visualize this, right? So go ahead and grab a paper. We are implementing C4 here, or case 4. So I'm going to, again, just simply pick up this one, 54321. And let us say that I would like to delete 3, right? If I want to delete 3, I know that current is 3 now, right? So because current will travel from all the way from 5 to 3, right? So all I do is current's previous node, current's previous node should point to current's next node, right? And vice versa. They both need to be connected. So in other words, we are trying to connect 4 to 2 and 2 to 4. You see, 4 would be connected to 2 and 2 would be connected to 4, right? So that's the change that we need to do. So first thing first is we need to do the current dot get previous dot set next. And what is this going to point to? Current's next node, right? Get next. All right, so that's that for the forward direction, which is for setting the chain from the previous node to the next node. But we need to set the next node to the previous node as well, right? So let's do that. Current dot get next dot set previous current dot get previous. Okay, so we probably want to add the get next parenthesis right here. All right, so that should nicely set up the chain here, where we are doing a current dot get previous dot set next and current dot get next dot set previous. We decrement size and we return true, right? And every single time we are going to go ahead and go to the next node in that sequence, and we only stop if the current node is equal to value, right? If none of these cases hold good, then it will simply return false, right? So that's the first try of our implementation. We may need to come back and modify if needed. So let's go ahead and add the link stub code right here, right? So I'm going to um, add the necessary code right here. I copied the dashes, so simply place the dashes. I like to have a while loop this time around for the delete. So let's add that while loop right here, while true, right? And then we need to do a char repeat is equal to scan dot next. Okay, and then we'll simply check if repeat is double equal to y, then continue, else break, right? So we ask a question before that, system.out.println, do you want to delete? Let's make this lowercase just for simplicity, right? So rather than uppercase, let's set this to be lowercase. All right, so we asked that question. If they want to delete, then so be it. We would delete that if if the user like to delete, right? Um, right. So again, we will ask a question right here. Is that what's the node that they want to delete, right? So tell us the node value to be deleted, right? So that's the input that the user provides, and then we will do a prompt equal to scan dot next end, right? We are getting the node to be deleted by the user. And then once the user provides that, so we will simply do, this time we will use link1 dot delete node. I believe it's delete node, right? Let's double check. Yeah. So link1 dot delete node, and then we pass the value or the prompt, right? So that should nicely set up the delete. Let me clean this up a little bit. All right, so that should set up the delete, and then I like to print the sequencing here. So simply copy that and put it right here to display the nodes in the forward direction only, right? And then you ask that question, do you want to delete again? If they say delete again, then we are going to go back and print that again one more time, right? All right, well, this is the initial start here. So let's see if this program would compile. And if needed, we will also fix some of these errors. Okay, so first thing first is I get a scanner error. Scan is missing. Yeah, so we never added the scanner, right? So we need to add the scanner. So let's add the scanner right here. New scanner. This time we would do system.in to stream in the data, right? And then import scanner. Okay, so we added that import statement, and then let's try. Okay, well, successfully compiled, right? You did a good job so far. Let's see if the program would run as it's supposed to be. So when I do a Java link stub, I get that printed correctly. Tell us the node value to be deleted. Okay, so I like to delete value 0, which is the head node, right? And you get 1, 2, 3, 4. Do you want to delete again? I would say S, right? And I say yes, it's not coming into the loop. We probably might be missing something. So let's go over that. Yeah, so it should be lowercase y. Let me update that, and then we will try recompile it, rerun it. Tell us the node value to be deleted. So I would say 0, and I would say y. Again, it's asking, what's the value to be deleted. 1, hit y again, 2, y again, 3, y again, 4. So then the list is empty, so you could simply say no, and it would exit the program, right? So again, this is how you would implement a typical delete scenario in a doubly linked list. And keep in mind, we had taken care of both the previous and next pointer all the way through, right? So what, you may ask a question, what if we don't implement one of these functionality, right? So let us say that if we are trying to delete the head node and we didn't do this, right? I'm just deleting the first 3 lines. And you could see if I would compile and run this program, tell us the node to be deleted. Look, if I can delete a node like 2, which is in the middle, no problem. I can delete 4. No, okay, well, I need to rerun it again. So it's asking me, tell us the node to be deleted. So I would say 2, then S, 4, right? Then I would say S again. And look, if I do a 0, which is the head node, then you can see that it didn't delete correctly, right? So it's still 0, 1, 3. You see? So that's the problem that we will encounter if we don't add the correct logic, right? So we need to add the correct logic right here, okay? All right, so at this point, I'd like you guys to take up an activity where you will implement your new method called search item or search node, right? And then let's say there's a value. I like you to add the logic right here, okay? And keep in mind, so we will also do this as Boolean, right? This is a Boolean. So Boolean search node int val, right? And add the logic right here to search a particular node is existing in the doubly linked list, right? So I will simply do a return false right here for now, but I want you to add the logic right here, right? So you may want to iterate through the list and then find if the concerned item with the value that's provided here, does it exist, right? So again, you may want to add a new while loop to do the search, right? So I will copy that while loop right here. Tell us the node value to be searched, right? And then you prompt that, and here you will simply say search node, and here you may want to based on the true or false here, right? So let's say Boolean result is equal to, so based on true or false, you may want to set up a if-else condition here. I'm going to just add the code. This is the activity that I like you to do. Set up the if-else condition and print to the user if the node exist or not, right? Based on the value that's returned in the res right here, right? So you may want to create an if-else condition, right? Add a if-else condition. And then do you want to search again? If they want to search again, then you ask that question again and you go back and do that, right? Um, but keep in mind, if the linked list is empty, you don't want to ask that question again, right? So add that concern logic. I like you to add one more logic right here based on the size of the linked list. If the linked list is not empty, then prompt the user for repeat, right? If the linked list is empty, then simply exit the loop, exit the while loop, right? You can break the while loop if the linked list is empty. All right. Well, I like you to work on these here, to make sure that you add the corresponding logic. So I like to see in your output window, after you perform all the delete, it should ask that tell us like what you want to search. If the node exists, you simply say that hey, the node exists, right? It's true, or you simply say it's false, right? Um, all right, please work on that and post your solution before 5 p.m. Eastern Time today to get the class participation credit. And again, you can use the GitHub Classroom link shared with you last time. And I would go over the commit history and I would see the most recent commit by you to get your changes for the doubly linked list, delete, and I should say the search operation. Okay, and I will end this video here.